Assalamualaikum and hello. In this video, we're going to present about our assignment, which is BMMP2343 control system. The title we chose is Application of Flush Toilet Control. First of all, I will introduce myself and my group members. My name is Zuli Aida Syairah binti Zulkifli, and my group members is Azrul Azizi, Lokesin, Nur Shazilina and Fadli Arifin.
Now I would like to discuss about our introduction of our group assignment. Current teaching are generally related to waste management system. In particular, the current teaching is about flush toilet. It includes a water supply to supply the bowl with a flush source. The control system includes a controller and a user interface. The controller operates the toilet through a flushing sequence in a first mode and a second mode. However, it is desirable that the amount of water used can be adjusted to suit the needs of different users. Although non-washrooms have proven to be acceptable for their intended use, there is still a need for continuous improvement in the art. Toilet flush control system include an electronic control and operate in a first mode and second mode. In first mode, the system operates to flush the toilet with predetermined amount of water. In the second mode, the user can adjust the amount of water sent to the toilet, and the controller will be automatically reprogrammed to repeat the adjusted amount of water during subsequent operation of the system in the first mode. In other aspects, it also provides a system for monitoring the current drawn by the macerator unit of a macerator toilet. The system may include a controller to cut off power to the chopper unit when a current outside the predetermined range is detected. The controller also works in normal mode and lock mode. The user interface communicates with the controller. This is the block diagram for application of flush toilet control and our signal flow graph for application of flush toilet control.
For the calculation of transfer function, we get G1S, G2S, G3S over 1 plus G1S, G2S, G3S times with HS. After we assume the value of GS, which is 4 over S squared plus 3S plus 2, then we substitute to the equation. Finally, we get 4 over S squared plus 3S plus 6. To get the value of peak time, we substitute the value that we obtain from the equation. Then finally we get 1.62 second. Next, for the percentage of overshoot, we substitute the value to the equation. Then we get 8.8%. Next, for the settling time, we also substitute the value to the equation and get the result is 2.67 second. And lastly, for the rise time, we put the value to the equation, then we get the final result is 0.79 second.
Next, I will present about state space representation. As you can see, this is the diagram of transfer function. This is the step that we use to convert the transfer function to state space. Next, we define the input variable as u equal to r1. To differentiate the step variable, x dot 1 equal to c dot equal to x2. Next, x double dot 2 equal to c double dot equal to 4u minus x3 minus 3x2 minus c x1. Next, we obtain the state equation in metric forms. The output equation that we get from the state space is ys equal to cs equal to x1, then y equal to c equal to 1, 0, 0 multiplied by x1, x2, and x3. The table shows how to get the stability of the system by using the Rose-Hart-Rite table to carry the calculation. Throughout the calculation, it proved that the system was stable since there are no sign change in the first column. Besides that, the Rose-Hart-Rite declares that the number of roots of the polynomials that are in the right half plane is equal to the number of sign change in this first column. Hence, the system was stable. Okay, next I will explain how to get the graph of the system response by using the MATLAB. First, we need to enter the MATLAB command, which is hash equal to tf transfer function open bracket and open square bracket. Enter the numerator value, which is 4, and close square bracket. Then comma, open square bracket, and enter the denominator value, which is 1 space 3 space 6, and close square bracket, then close bracket. Insert semicolon and enter. Next, we need to type step plot and call back hash. Then enter. Okay, the graph will obtain. To see the rise time, we need to right click. Okay, characteristic. Then select the peak response. Okay, so we know that this peak at time 1.63. Okay, next click right characteristic and select rise time. Okay, then the rise time is 0.77 second. Okay, next is for characteristic 2, and we need to select settling time. Same, we click and we know that the settling time is 2.44 second. Okay, next the step is also similar. Click the right click characteristic, and we need to click the transient time. Okay, next we need to get the info by type the add command step info and call back the value of hash, open bracket, capital hash, close bracket, and click enter. Okay, the value will obtain as we can see in the screen, which is the rise time 0.7877, transition time 2.44, settling time 2.44, settling minute 0.60, settling maximum 0.73, overshoot 8.77, undershoot 0, peak
So, for
0.73,
our
and the peak
discussion
time is
or analysis,
1.63.
based on the assignment, students are required to select one of the second system in any engineering application. We have decided to choose application of a flush toilet control. These systems are able to control the water filling inside the toilet tank. We will also being able to produce the block diagram for the application of a flush toilet control. According to the block diagram, we figure out that the flush toilet control are closed loop system. This system use electronic or mechanical device that automatically regulates a system to maintain a desired state or set point without human interaction. For the transfer function GS, we assume that the GS is 4 over S square plus 3S plus 6 for the preferred input. From this transfer function, we have obtained the graph of the step response by operating a simulation using the MATLAB software feature. From the graph obtained, we were able to identify the peak time, rise time, setting time, and percentage overshoot.
In conclusions, we have learned that the combination of block diagram and transfer function is a powerful way to represent control systems. Transfer function relating different signals in the system can be derived by pure algebraic manipulation of the transfer functions of the block by using block diagram. In this assignment, we use application of a flush toilet control to control the water filling inside the toilet water tank. The buoy can be an actuator output by calculating proportional integral and derivatives responses to compute the output. As this system is a closed-loop system, the buoy is a sensor is used to measure the process variable and provide feedback to the water filling in the control system. Based on the system response that we obtain by using the MATLAB software and manual calculation, this control system of flush toilet control is considered stable. That's all from our presentation. Thank you.